Hello to anyone tuning in to my first live stream. I will be covering exponent rules today. So I just now shared the problems we'll be looking at. And so I'll cover some of this. For those who don't know about exponent rules, it can take quite a bit of time to cover them. Because there are quite a few exponent rules, but I'll get through as many problems as we have time for. And I want to go at a general pace, so not too slow for most people, but also not too fast for most people. That's my goal for today. So I want to start with just reviewing what exponents are before we start with these problems. So I'm going to take an example of an exponent, and I will be putting this just at the top of the screen. And so let's look at just an exponent like 5 to the power of 2. Okay, so in this example, 5 would be what we call the base. The base is the bottom number, the big number. And then 2 would be what we call the exponent or the power. So that's like that top smaller number. And so the 2 just tells us how many times we'll be multiplying the 5 by itself. So 5 to the power of 2 would just be 5 times 5, which is 20. Taking another example, 5 to the power of 3 would be 5 times 5 times 5. So it's telling us we multiply 5 by itself 3 times, which is 125. So that's what an exponent is. So then we have exponent rules. And that's what we'll be doing today. So let's start with the product rule. The product rule states that when you are multiplying with exponents, you add the exponents together. So I like to generally start with simpler problems than the ones they have here, just to illustrate the idea first. So we said the product rule is when you're multiplying with exponents, the way you do that is you add the powers. Okay, so an example would be, let's say you had a problem like x to the power of 5 times x to the power of 3. So here we are multiplying. We have the same base, so that's important. The same base, it's x. And we said we add the powers. So this will keep the base the same. It's still x. It didn't change at all. And then you're adding the powers. So it's 5 plus 3. And so this becomes x to the power of 8. So this is called the product rule. So now let's start to go to some more complicated problems like the ones that are in this worksheet. Okay, so let's look at number 1. So what you want to start by doing with number 1 is you would multiply the numbers that are there first. So just the numbers. So you will see like x squared doesn't have a number. So there's an invisible 1 there. Anytime you don't see a number, it just has an invisible 1 because anything times 1 is itself. So we have 1 times 4, that's just 4. So there was no exponent rules there. We just did 1 times 4, nothing crazy. Okay, now we're going to look at x squared. We have x squared right here, and we have x. So we have x squared times x. So x squared times x, we have to do exponent rules here because we have exponents. And we're not including that y squared because that has a different base. So let me just put that down here. You won't, once you become like good with these, you won't have to write down each and every step as I am doing now. But when you're beginning, I recommend you write it down. So x squared times x. As I said, when you don't see a number, there's an invisible 1 there. So we have an invisible 1 here. X is the same as x to the power of 1. So you just add the exponents. So it's x to the power of 2 plus 1. And that's x to the power of 3. So far we have 4. X to the power of 3. And then you see just that y squared there. And there was no y in the first part of the problem. So there's nothing to do with the y squared. It just attaches to the end of the problem. So this is our answer to the first problem. So then let's go to another problem. Let's try number 4. Okay, so same thing. We're going to multiply the numbers first. 7 and 2. 7 times 2. It's 14. Okay, now x times x squared. So we try that. Remember, there's that invisible 1. So x is the same as x to the power of 1. So x times x squared, 1 plus 2 is 3. That becomes x to the power of 3. Okay, and then we have y to the power of 3 times y. And you should get y to the power of 4 for that, because 3 plus 1 is 4. So you should see how we're keeping the bases the same. We're just adding the powers. Okay, let's do another one. Let's try one with negative numbers now. So let's try number 10. So same thing, -2 times 5, -10. And I'm assuming prerequisite knowledge here. So if you need help with negative numbers and more basic math, some of this might be difficult to follow along with. So it would be good, of course, if you don't know a lot of this basic math, to consider private lessons. Then we have x to the power of 4 times x to the power of 6. So you have, again, keeping the base as x, and we add the exponents. 4 plus 6, that's 10. And then we have y cubed times y squared, keep the base the y. And then do 3 plus 2, that's 5. So we have y to the power of 5. So this is the product rule. You add the exponents when multiplying with bases with exponents. Okay. So now we'll go down to the quotient rule. The quotient rule, it's when you're dividing with exponents, what do you do? So it's the opposite, you subtract. So with the product rule, we added the exponents. With the quotient rule, we'll subtract the exponents. So again, let's take a problem that's easier than what's on this worksheet just to see the point. So let's say we have x to the power of 5 divided by x to the power of 3. So we keep the base the same. The base is still x. Nothing happens to the x. And then we subtract the exponents since this is division here. So we have 5 minus 3. And so then that's x to the power of 2. Okay. So whereas in multiplication, we added them, 5 plus 3. In division, we subtract them, 5 minus 3. Simple enough, right? So let's now go to some problems. Okay, so I'm going to start with one like number 15 because it doesn't get, it's very similar to the one we just looked at. And then we'll go to some more complicated ones from there. So just as in the multiplication ones, how we multiplied the numbers, we'll divide the numbers with the division ones. So just doing like normal division. You have here 15. Like if you, for doing number 15, you have 15 divided by 5. So you just do that. You just divide the numbers. And that is 3. And so there was no exponent rules there. You just divided the numbers. Then we have x to the power of 5 divided by x to the power of 3. Well, we just did that. And we had to subtract the exponents, right? Since we were dividing with exponents. And we got x to the power of 2. So this is 3, x to the power of 2. Okay, let's take another example. Let me see a good one. Okay, let's try number 18. So we have 10 divided by 50. So when you have a small number over a big number like that, that's a fraction, right? So you just want to simplify the fraction. So again, assuming prerequisite knowledge here, I'm assuming you know how to do that for the purposes of this video. And so like 10 over 50, we simplify it, right? And that's just 1 over 5. Let me just erase that so it doesn't get crowded on this worksheet. All right. So we have 1 over 5. Instead of 10 over 50, we write 1 over 5. Then we have x cubed over x squared, right? X cubed over x squared. So because we're dividing, we have to subtract those exponents. The base is still x. Then we have 3 minus 2 is 1. So it's x to the power of 1, which is just x. I'll leave it as just x. And then we have y to the power of 4 divided by y cubed. So the base is y. And then we have 4 minus 3, which is 1 again. So y to the power of 1 or just y. So this becomes 1xy over 5. You don't need that 1 there again because anything times it's 1 is anything times 1 is always itself. So just write this in a more in a neater format. So xy over 5 would be our answer. Okay, let me try to find another good one. Let's look at number 21. Some of these, I'm trying to avoid doing the negative exponent rule for now because that's another rule. The one we'll do next, just because I want to make sure you all understand first the quotient rule. So I'm trying to avoid the ones that have the negative exponent rule in it. So yeah, let's do number 21. Okay, so again, we simplify the fraction 48 over 56. And when you simplify that, you should get 6 over 7. Then we have x to the power of 2 divided by x to the power of 2. So the base is x. We have 2 minus 2, that's 0. X to the power of 0. Anything to the power of 0 will always be 1. So, and there's no need to write the 1 there. So that just cancels out. You should also know as a basic math skill that when you have the same thing on the top and the bottom, the exact same thing on the top and the bottom, it cancels out without using exponent rules. That's just a general rule of math. And then we have just that y squared on the bottom there, and there's no like y squared on the top. So there's no math that needs to be done there. We just attach that. And so this becomes our answer, 6 over 7y squared. So this is what we have for the quotient rule. Just going to take some water. I'm not really used to talking this much. Normally, I like the student does quite a bit of talking that I work with. And we solve the problem together. I don't just talk the whole time. So this is quite a bit different from what I'm used to. So, okay, let's before we get into the negative exponent rule, let's take a look at these two problems at the top that I skipped over. So let's do let's see, 13 has the negative exponent rule, so I'll skip over that. Let's do number 14. Okay, so we have, and it works, so it works the same. Like if the base is a number, it still is going to stay the same base. Nothing changes if the base is a number. So some students like think that exponent rules go out the window or something crazy happens if the base is no longer a variable, but no, exponent rules are still the same. So we have 3 cubed times 3 squared. Your base is what? It's 3. So we keep 3 as our base. And we have multiplication here, right? So remember, what do you do when you have the product rule? You add the exponents. So it's 3 plus 2, that's 5. So we have 3 to the power of 5. Then on the bottom, we have 7 squared times 7. So 7 is your base on the bottom. And then it's 2. And remember, there's that invisible 1 there. So 2 plus 1 is 3. 7 to the power of 3. Okay, so now we need to simplify these guys. And hopefully you have some pretty good mental math skills. So if not, I do teach that in my tutoring. So we'll do 3 times 3. So 3 to the power of 5 is just 3 times 3 times 3 times 3 times 3. Hopefully I said that out loud correctly, but I wrote it down correctly in any case. So 5 3 should be there on your paper. And so we'll take this one step at a time. 3 times 3, that's 9. Okay. Now then 9 times 3, the next 3, that's 27. So far, we just have basic multiplication facts that you should know. Okay, then we have 27 times 3. Okay, so now we start to get into scary territory, right? But it shouldn't be, because 27 is just 25 plus 2. So instead of doing 27 times 3, that's the same as 25 times 3 plus 2 times 3. So if you know the mental math skills for these types of things, then it's really helpful. And so that's just 81. And then we have 81 times 3. And so 81 is just 80 plus 1. So we have 80 times 3 plus 1 times 3. And that's 243. So 3 to the power of 5 is 243. That's what we have on the top. And then we still have to do 7 to the power of 3. So let's do that. So that's 7 times 7 times 7. So starting with basic multiplication, 7 times 7, that's 49. And then we have 49 times 7, right? So you either have to do some long multiplication on your paper, or you could just realize that 49 is 50 minus 1, right? So you would do 50 times 7 minus 1 times 7. And that is 343. And so this is our answer. Now, again, with the prerequisite stuff, so far we've had negative numbers, we've had mental math, and we've had simplifying fractions. I sort of went really quickly through that. If we're like going, if I know that you don't know it, if we're in a session together privately and I know you don't know it, and we're covering basic math skills, I'll of course go at your pace, at a much slower pace if I know you know it, or if I know that you have a really good foundation, I might go faster than I am now. I'm trying to just go at like a general pace and assume prerequisite knowledge. Otherwise, I could just be here all day and not and cover like a lot of things that are unrelated to exponent rules, and be guessing. So I'm trying, so like when it's one-on-one, like I know what pace to go at with an individual student. When it's like this, I'm just sort of trying to go at a general pace. So if this looked like intimidating to you, the mental math, because I know that with a lot of my students, mental math in the beginning can be really intimidating, especially. Don't worry, like we would cover it at a lot slower of a pace than I just did. Okay, so we're going to end with one more exponent rule for today. We're going to do the negative exponent rule. And so the negative exponent rule is simply how you simplify the exponent at the very end. And it states that when you have a negative exponent, you move it to the other side of the fraction and make the exponent positive. So as an example, let's say you had 1 over x to the power of negative 5. So we have 1 over x to the power of -5, and we want to simplify that. What we would do is we don't want a negative exponent in our answer. So we would move it to the other side of the fraction. So since it's in the denominator now, it would go to the numerator. And then we would make the exponent positive. So it would become a positive 5. And so it would become x to the power of 5. We moved it, the whole thing, to the numerator, and we made the exponent positive. So let's take a look at a problem with the negative exponent rule, just so you can see how this works in the problems. Okay, so let's do number 16. So with number 16, we have the numbers first. So that's 16 divided by 4. So that's just 4. And then we have x to the power of 3 divided by x to the power of 5. So this time we have 3 minus 5. That's -2. So it's x to the power of -2. So as I said, you can't leave it as a negative exponent. You can't leave it like this. You're going to have to simplify it using the negative exponent rule. And what does the negative exponent rule state? It states you move it to the other side of the fraction and you switch and you change it to a positive power. So we move and you're not moving the 4. That's a mistake that a lot of students just starting this make. You're not moving the 4, you're only moving the base and the exponent. So it'll be you're moving the x and the 2. Okay, so you're going to move, you're keeping the 4, that's still going to be where it's at. And since the x to the -2 was in the numerator, it's going to the denominator. So it'll be x to the power of 2 in the denominator. Okay, so we have 4 over x to the power of 2 for our answer. So we simply took the x to the -2, and we moved it to the denominator. And then we switched the sign. We made it positive. We made the exponent positive. Okay, so now let's take a look at another example. Let's do number 20. Okay, so with number 20, if we simplify that 50 over 200, we should have 1 over 4. And then we have x over x cubed. So x is our base. And then we have, and then it's 1 minus 3, that's -2. So I'm just going to write it as 1 x to the power of -2 for now. And then we have y cubed over y to the 4th. So 3 minus 4 is 1. We have y to the power of -1. So that's what we have so far. And it's getting a little crowded on my worksheet. So give me a second to just erase this. Okay, that's better. So we have 1 x to the power of -2, y to the power of -1 over 4. Because we had simplified 50 over 200 to 1 over 4. X over x cubed became x to the power of -2. And y cubed over y to the 4th became y to the -1. So now what do we have to do? We have two bases here with negative exponents. We can't have negative exponents. So we need to move those. we need to simplify those. So we use the negative exponent rule. We will need to put them on the other side of the fraction. So they're in the top of the fraction right now. They're in the numerator. We'll move them to the denominator. So we have 1/4. Just write that down. And then we move them to the denominator. And do you remember what happens to the exponents? They become positive. So it's 4x² y to the power of 1, which is just y. So this becomes our answer for this problem. So we've done quite a bit today. I will show you one more. This one, it's with numbers. And it also has the negative exponent rule. So number 13. So we have multiplication in the beginning, 5 cubed times 5 to the 4th. So our base is 5. And then we add the exponents. 3 plus 4 is 7. 5 to the 7th power. Then we have 5 to the power of 9 times 5 on the bottom. So adding the 9 plus 1, we get 10 as our exponent on the bottom. So we have 5 to the power of 7 divided by 5 to the power of 10. So you should note that we simplified the numerator and we simplified the denominator first. Just we made this fraction organized first. So now we do 5 to the power of 7 divided by 5 to the power of 10. That's division rule, right? So our base is 5. 7 minus 10 is -3. So we have 5 to the power of -3. We have a negative exponent. What do we have to do? The negative exponent rule. So move it to the other side of the fraction. It's in the numerator now. Since it's just a whole number, right? It's just 5 to the power of -3. That's the same, I should mention, as 5 to the power of -3 over 1. So that's what I mean by the fraction. Like, even if you don't see a fraction there, you can always make it a fraction. So it's in the numerator now because it's just a number. It's not on the bottom of anything. And so we'll move it to the bottom. And we have to make the exponent positive. Always remember to do that. That's the point of moving it. And put a 1 on top because we have to have something on top. And then we can simplify that 5 to the power of 3. So 5 to the power of 3 is just 125. Okay, so I'll stop here. Now, when you just watch somebody do all these problems, it's not necessarily the best way to learn. You need to actually do the math yourself. So that's what I always like have students do. I have them actually doing the math themselves. If they get stuck, I'll help them through steps, but they're actually getting to the next step themselves. I'm not just like giving it away like I am here. So that's the important thing you have to realize. To actually learn this and feel comfortable with it to the point where it's not overwhelming, you need to actually do it so much. And that's how I became good at it. I did so much of it. So that's what I recommend. After watching this video, if you feel like you have the math basics down and you understood a lot of what I said, pull up a bunch of these problems and start to practice them. So actually do them. And for those who are wondering, I'm using Effortless Math. It's a very good resource for the ASVAB and for math in general. Okay.